Okay, get through this review, and at the very end, I'm going to show you also some flashcards to help you study and make sure you do your rules correctly. So, this table that you have up here on the first page, trying to get this to minimize, maybe it won't. Alright, so everything here on this first page you need to memorize. I would maybe do some flashcards, everything here. Um, all the way down. Um, and so I'm going to go back up. You can pause the video if you need to copy this down, but you're going to be responsible for translation rule. The coordinate notation is some type of mapping from your x and y coordinate. So if it's a translation, you have adding. That's why you have x plus h, y plus k. Some type of adding or subtracting to x and y. Just remember, like if you're moving to the right, that's positive direction. To the left is negative direction. I probably should have did that in parentheses. If I'm moving up, that's positive. I'm moving down, that's negative. So sometimes they might give it in words, or you might need to just physically do it if you have the plus or minus. So here's our rules. Reflection over the x-axis, x stays, y changes to the opposite, the sign, that's what we're referring to. Over the y-axis, the y stays, the x changes to opposite. Y equals x, you switch the order, and y equals negative x, you switch and you change the signs to the opposite. So that's our first set. Then we get into rotation. You need to memorize these three rotation rules. 90 is negative y comma x. So we switch or flip the order and change the y to the opposite sign. 80 is negative x, negative y. So we're just changing the sign to both x and y to the opposite. And rotation of 270 is y comma negative x. So this is when we're switching or flipping the order and changing the sign of the x. Then for dilation, make sure you recognize when it's an enlargement. That's when the scale factor, that's our symbol k, is greater than 1. Reduction is when it's between 0 and 1. And so we're multiplying. I have on here, because you're doing this for both, instead of showing it in words for both, understand that this is happening whether it's a fraction or a number greater than 1. You're going to multiply the x and the y by the scale factor for an enlargement or dilation. Stretch is, we can have horizontal stretch or vertical stretch. That's when our scale factor is greater than 1. And horizontal, you just multiply the x only. So we're multiplying by x only by the scale factor. Vertical is when we multiply the y only by the scale factor. And we can do that. A compression is when it's between 0 and 1. So we're looking at fractions or decimals. So like I said, pause, rewind, get your table filled. We're going to go straight into the application. So you're going to have some problems asking you to identify an enlargement or a reduction. We know it's enlargement when k is greater than 1. And it's a reduction when the scale factor k is between 0 and 1. So our first one here, because our scale factor is 3/4, that is between, this is between 0 and 1, this is a reduction. Now on our number 4, the scale factor is 4/3, okay? 4/3 is the same as 1 and 1/3, so that means it's greater than 1, so this is an enlargement. Now we're going to apply some dilations, okay? So this is just some recap. Oops, let me fix that real quick. There we go. All right, so I went ahead and did the pre-image, ABC, the triangle. Just remember our x-coordinate, that's our first number, and our y-coordinate, that is our second number. And we're multiplying our coordinates by the scale factor of 2 on this problem. Because right here it's the dilation of d equals 2, and right here, that's what I kind of explained. D equals 2 equals a dilation with the scale factor of 2. So we're doing 2 times x and 2 times y for each one. So a prime, since I'm doing 2 times a negative 2, this would be negative 4, and 2 times 2, 4. So there's our a prime. Let's do our b prime. Remember, we're taking 2 and multiplying by the x, which is our 1, and we're doing 2 multiplying by the y, which is our 3. So we should have 2, 6 here. And then c, same thing. Hopefully you can do it mentally. If not, write it out. Use your calculator. We should have 2 comma negative 2. And then we're going to graph those points. So there'll be times when we are going to ask you to graph the prime, the image. So here we got negative 4, positive 4. There's my A prime. Positive 2, positive 6. So to the right 2, up 6. There's my B prime. And then we have 2, negative 2. There is my C prime. And then we can connect those and see that actually got bigger. Okay? So there's a dilation with scale factor 2. Here we have a translation. Translation means we're going to have to add capital T's for translation. And we have, this is vector component form, but basically we're doing sometime addition to the x's, sometime some type of addition to the y's. So this is write the translation pattern. Okay? Since we're writing the pattern, we have to look, what's the pattern between the x coordinates? The x coordinates are negative 9 to negative 6. So what did we do here? We had to add 3 to make that a negative 6. Then we look for a pattern between the y coordinates. We have 12 to 2. That's minus 10. If I subtract 10, I'll end up with 2. So now I can see that my pattern, my coordinate notation would be x plus 3, comma y minus 10. And now they want us to apply the above rule to the following points. So for f prime, because we're adding 3 and our coordinates, our x and y coordinates, the 0 is our x, the negative 3 is our y. So to get our prime, we're going to do 0 plus 3, and then we're going to do our negative 3, which is our y, negative 3 minus 10. We're just plugging into the form. So f prime would be 3, comma, negative 13. Why don't you try g prime? Some of you probably already did that in class, but just try. Pause the video if you need to. We're going to add 3, subtract 10. Hopefully we got our g prime was negative 2, comma, minus 3, negative 3. So that's using translation rule. You're definitely going to see one like that, determining the rule and then applying the rule. Now, we're going to complete the transformation for each following the rule. What's on the top column here is the rule. And if you look, because we have 1/4 times the x and 1/4 times the y, we're multiplying a fourth times the x and the y. And just again, I probably should have did that. Let me fix this. Maybe this might help you see it a little bit better. That number we're multiplying by is our scale factor. So we're taking our x, that's the first coordinate, our y is the second coordinate, and we're going to multiply 4 by it. So if I was to physically do that on the calculator, if I hit Control, divide, I get my fraction bar. I want the 1 on the top, the 4 at the bottom, and then I need to tab to the right so that I can do the times. Can't do the times with the 4. So we're doing 1/4 times 8. Enter, and we get 2. Okay, so we did a fourth. Oops. 4 times 8. And then we're going to do a 4 times 4. And our answer was 2, comma 1. Okay, 2, comma 1. Now this rule says we're going to keep, oops. This rule says we're going to keep the x the same, but now we're going to do 3 times the y. Okay, keep the x the same, and now we're going to do 3 times the y. Same point, 8 and 4. So this would be 8. And then we're doing 3 times the 4, the y, that would be 12. Good job. So now we're multiplying 4 to both. So we have 32 and 16. Now we're multiplying by 0.5 to the x and the y. So use your calculator if you have to. 0.5 times 8 and 0.5 times, is it 4? Can't remember. Yeah, times 4. So we have 4, 2 as our answer. So this would be 4, comma 2. All right, so try to apply the rule for our new set of points. Again, first coordinate is your x, second coordinate is your y. Okay, first coordinate is your x, second coordinate is your y. So here, we're going to have a fourth, oops, apologize, a fourth times negative 12. That's when we're multiplying just the x coordinate. Oops. And do, yeah, this was our x's. Then we're going to do a fourth times 3. And that's when we did our y coordinates. Okay, 4 times the y. Now, I'm going to simplify underneath this. I can put that in the calculator, but a 4 times a negative 12 is a negative 3. And in the calculator, if I did control divide to get the fraction, and I had 1/4 times 3, we got the fraction 3/4. And so you can get a fraction answer. I don't want you to get discouraged. So that's 3/4. Now, x stays the same. X. We're going to 3 times y. We should have 9 here. Good job. Let's try this one. Multiplying 4 and x by, x and y by the 4. We should have negative 48, comma 12. Good job, you got that. And then we're doing 0.5. Use your calculator if you need to. Check your answer. We should have negative 6, comma 1.5. Okay. So use your calculator when you have to. And that will take care of our first 2 pages, the table. So fast forward the video or just hit the right arrow button to get to the next step. Thanks.